This is 7.4. SOHCAHTOA continued, right? The sine and cosine ratios. So very important, guys, to, I can't stress this enough, have an idea of what these ratios are to be able to conceptualize them, okay? All they are representing a ratio of a side length over another side length, okay? The sine ratio is the opposite over the hypotenuse. The cosine ratio is the adjacent over the hypotenuse. And the tan ratio is the opposite over the adjacent side. Okay, knowing that, you should know that sine theta can never be greater than 1. Why is that? Because the opposite side can never be greater than the hypotenuse. Likewise, cos theta can never also be greater than 1 because the adjacent side can't be larger than the hypotenuse side. But the tan theta can be greater than 1 because the opposite of the adjacent side can be bigger or smaller than each other. Okay? So if we recall, sine and cosine ratios must always be between 0 and 1 and 0 and -1 for the reasons that I just told you. Okay? For the triangles below, identify the adjacent side, the opposite side, and the hypotenuse, and use your definitions for the ratios to find the trigonometry ratios requested. So, to find the sides of the angle of interest, I would personally always start with the opposite. Because you find the angle of interest, that should be the first thing your eyes are looking at, and then you're going to go to the opposite side. So it's 6. Once you have the opposite side, you can then identify the hypotenuse, which is opposite the right angle, and then finally the last side is going to be the adjacent side. So adjacent side, opposite side, and hypotenuse. All right? Once we have those, we can then figure out our ratios. So sine angle A, everything is about angle A, so it's going to be opposite, 6 over 10. Cos A would be adjacent, 8 over hypotenuse, 10, and tan A would be 6 over 8. Okay? Now, to find A, we could use all three of these. If you do on your calculator, sine -1, 6 over 10, cos -1, 8 over 10, tan -1, 6 over 8, you're going to get the same answer for every single one. Okay? That's how these ratios work. 37 degrees, yep.
Why do you inverse it again?
Okay. Why do you inverse it? So you have this set up. You're okay up to here, Ethan? Okay. The reason you inverse it is just like we want to solve for A by itself. So the way we can get rid of sine is we do sine to the -1. Now sine to the -1 is just like 1 over sine, right? So if it's 1 over sine, just like these signs will cancel. Do you see that?
Oh.
You know how like 5 to the -1 is equal to 1/5, like that? Right? So it's the same idea. You're just trying to cancel out sine. So you're doing sine to the -1 to both sides. You end up with angle A on the one side.
Oh, so A would just be that, and it would be the same for everything.
Yeah, so for this one, cos angle A is equal to 0.8. If you do cos -1, it's the same as saying this over cos, right? This over cos. Right? So you're canceling these coses out. You get angle A. And then what you're left is cos -1, 0.8. Okay? You get it? Good. All right. So we have our ratios here. We've converted them to decimals, I guess for easier entering into your calculator, possibly. You can do that first. If you have a good calculator, you can just put in the brackets and do your division and get it all in one line. Okay, next one. The angle of interest here we can see is B. Okay, we know that because of this line here. All right. And so we're going to determine our sides. First we're going to go opposite. Then we're going to go hypotenuse. And then we're going to go adjacent. All right. Once we have our sides, we can determine our ratios. Sine B would be opposite over hypotenuse. So opposite, 24 over 25. All right. Cos B, 7 over 12. Tan B, 24 over 7. B is equal to 74. And you'll get 74 degrees with all of these. They're all going to give you the same value of B. All right? Next. label the other acute angle as angle M, and determine the three primary trigonometric ratios. So here's my other acute angle. Remember, acute means less than 90 degrees. So it's not the hypotenuse. So the acute angle is M. And now I want the ratios for M. So I'm going to go opposite, which is now 7 over 25. Cos M would be 24 over 25. Tan M would be 7 over 24. And M is 16. Any questions there? Super duper easy 2 questions to start us off. Compare your results from part A and B. So it's asking us to look at the results we got from A and look at the results we got from B.
Wait, sir.
Yeah.
We get M by adding them all up, right? Or is it the same number?
Angle M here.
Oh, but never mind. Sorry, it's the same number.
It's asking us here to compare results from parts A and parts B. So I'm thinking M and angle B. So basically, we found out that B was 74 and M was 16. So if we want to compare those results, we can see that they add up to 90, which they need to, right? So we know we've done this correctly. So both angles, or I should say all angles, add to 90 degrees. All right. Very easy. We can keep going. Example 2. Use your calculator to evaluate, round to 3 decimals. Ensure your calculator is in degree mode. All right, who can give me the answer to this? You're just going to type in your calculator, sine 22. Come on, everyone has to do this. Douglas.
0.37.
37.
4.
No, not 4. 5. You see why it's a 5?
Yeah.
Okay. Who's got the next one? RC. Now you're going to press 49 and then press cos.
0.75.
5. What's the last digit?
5.
No, I didn't get that actually.
Oh,
You did cos 49?
yeah, no.
That's what you got? 0.75?
Sorry, 0.656.
656. Good. Okay, Alan. Tan 60, Alan.
1.7. 1.73.
Okay, Alan, how come tan can be a positive value here? Like above 1. Why? Tells you something about the two sides that tan's looking at.
Oh, it's talking about
Soka Toa. Toa. What is Toa telling you? Come on, I want you guys to understand this conceptually, not just like how to answer the question. Lucas? Sorry? Opposite over? Did you say it, Jason? What did you say? Opposite over hypotenuse for tan? Never mind, Milkius. Opposite over adjacent, you're right. So what does that tell us then, if this is a positive number? What does that tell us about the triangle? Opposite angle? Yeah, the opposite side is bigger than the adjacent side. Yeah, that's what it tells us. Good, very good. Yeah.
When I did it on my calculator, I got √3.
Root 3 for what?
It's the same. I got that.
For 1060?
Yeah.
Yeah, there should be like a degree answer to degree button, like a switch button. You can get it in decimal. But if you put √3, I would have given you that as well. All right, Next one. Now we're using the cos -1 here. So guys, practice this. Practice makes perfect here. You're going to put in cos -1 and then 0.437. Make sure you get 63 here, 65, and 39. Practice that. If you can't get these answers, you're not even going to have a chance on the word problems. Because even if you know exactly what to do, you don't know how to use your calculator, it's going to be a problem. Now, if you want to put fractions in, you need to put the brackets. Some calculators do it automatically. Others, you have to press sine and then bracket. Okay, so like for this one, in my calculator, the way I had to do this one was sine, and then I had to press bracket, and then I had to press 5, then press divide, then press 8, then press close bracket. That's how I had to do this one. Oh, sorry, sine to the -1. Okay? See that? Sine to the -1 here. And then I press bracket. And 5 divided by 8, close bracket. That's how I got 38.68, which is 39.
So
Yep.
we use inverse to get angles, right?
Yeah.
And we use the regular.
To get the ratio. Or to get a side length, to be honest with you, right? Like if you had this, Ethan, you knew the angle and you knew one of the side lengths, but you didn't know the other, right? Then you would use sine to solve this. You're going to get a decimal value between 0 and 1, and then you would cross multiply this, right? Basically, you get C is equal to 5 over sine 33. That's what you would get. Okay? All right. Next question. Solve the following triangle using only trig ratios and inverse trigs. Okay, so no Pythagorean theorem. If you were to use Pythagorean theorem on the exam, you would get this wrong. Even though you have both sides here, well, you only have one side to start. I feel like we did this one.
Yeah, we did.
Did we do this one?
Yeah.
Yeah, we did this one. All right, let's skip it. Yeah, we did that one. Let's skip it. Example 5. Label the vertices. Solve the following triangles. So, it wants us to label the vertices. So we could say A, B. Actually, we would say X. Remember I said this before? You want to use the capital letters of the side length little letter. So this is Y, and I guess we'd call this H.
For example 4, why did you multiply instead of divide? Like for B?
Where?
For
B?
You multiplied 250 by 10.
Yeah, because we're cross multiplying here to solve for B. The reason we did it is because you're going like this. 250, 250.
Oh.
This cancels. B is equal to that.
When do you divide? Or
Why do I divide by 250?
no, like when?
When?
Yeah.
When the ratio is tan 25, so it's the opposite, B over the adjacent 250. That's why it's divided. Do you understand that? Do you understand why I multiplied both sides by 250 to get rid of
I
it?
know, but when do you divide?
Every example you divide. All these ratios you divide. If it's tan, you divide by the adjacent side. If it's cos, you divide by the hypotenuse. Every single one we're dividing.
Oh.
Always. Okay? Let's see some other examples. You can see everything is divided because it's always a ratio. So it says, label the vertices, solve the following triangles. So what does it mean when it says solve the triangle? What does that mean? We covered it yesterday. Ethan. Let me know.
Is it when you get all of the information on the triangle?
Like what?
Like all the angles and all the side lengths?
All the angles, all the sides. That's what it means by solve. Okay? So here it starts us off with, actually I don't know what it starts off. I think these were written in 60 and 30. I think it just starts us off with X and 16. That's it.
30, 30.
30
Oh, 30 is given?
Yeah.
Oh, okay. So it gives us one angle. So it gives us both angles because we take 90, right? 180 minus 90 and 30 gives you 60. So we have all the angles. So cos 30 is going to be equal to your opposite, your adjacent side, y, because it's next to cos, over 16. Once we have that, we can solve for y. Side length y is 13.9. That's here. Okay. Then we do sine 30, which is opposite, which is x over the hypotenuse 16. And then we cross multiply here to isolate x by itself. We're just really multiplying this by 16. And we get x equals 8. Any questions here? Yep.
Where did we go? 4.
4? Where? This is a y,
Oh.
not a 4. Y here. Okay? All right.
Sir, sorry. Can you go over again how you brought the sin 30 to the other side?
I personally wouldn't. I would have just left it on this side. So this is what you had, right? So I would have just said x is equal to 16 times sine 30, right? You don't have to bring it over, but you can switch these, right? You can switch this one so they both stay the same sign. You can do that because it's an equality, right? So I mean you can, but you could have just solved it with x on the right. Whatever. All right. Next one, we want to solve the entire triangle. Here we just have, looks like one side length. Do they give us anything else?
Yeah.
Give us 7 this.
Oh, this?
Yeah.
Okay. So,
7 and 11.
and the 11 here? No, this. Yeah, this. Okay. Yeah, that's enough because we'll use tan, right? So what we can say then is angle B, here this angle, is going to be tan, so opposite over adjacent is 11 over 7. And then we solve for angle B. We get 58. Okay? Once we have that, we can check angle A by subtracting 90 from 58 is 32, because the other one is 90, so 180 minus 90 minus 90 minus 58 is 32. So we got angle A, we got angle B, we got angle C, we got one side length, we got the other side length. We just need to get the hypotenuse. We're not going to use Pythagorean theorem, even though it would work. We're going to use our sine ratios. So let's use sine of A. So we know A is 32 is equal to opposite 7 over my unknown hypotenuse, h. Okay, so now I can just swap these. H is equal to 7 over sine 32, which is 13.21. I can look back at the problem. Does that make sense? Yes, it does. Any questions? Last one. Flying through this section.
Mister, can you start that one?
Yep. Oh, I missed this page. Did I? Yeah. Yeah. My bad. Thought we were almost done. Okay. Draw and solve the triangles. So it makes us draw this here, triangle ABC, with angle B is 90. That's easy. Angle C is 37, so we know that's the smaller angle. And then we have BC, the length BC is 8, and that's it. We can get this other angle A, right, by just subtracting 90 from 37. Right, we know this is 53. Okay, so we need to solve it. So we actually need to solve all of the information here. It looks like the first thing we did was tan, and we got tan is equal to AB. Tan 37 is AB over 8. So we solve for AB, which is 6. Okay, then we have 6, 8. Now we solve for the hypotenuse, AC. So we can say sine 37 is equal to 6 over h. And then h is equal to 6 6 divided by sine 37. 6 divided by 9.97. Okay, so we have all the angles, we have all the sides. Oh, we have it listed here as 10. Any questions? Next one. We are going to create the triangle. Q is 90, so always put it like, in the corner. Nice right angle triangle. QR is 5, so we're given this. And PQ is 11, we're given this. A lot of information now. We can solve for one of the angles by using tan. So we say tan R is 11 over 5. So the tan inverse 11 over 5 is the angle R, 66. Then once we have 66, we can do a little math. 180 minus 90 minus 66 is 24. Once we have angle P, we can then solve for the hypotenuse. We'll say sine R is the opposite, 11 over PR, the hypotenuse. Solve for PR, 12.08. Really, really, really easy. Nothing new here. Okay, finally we get a bit of a word problem. This, in my opinion, the hardest part, like any word problem, is going to be the setup. Setting this up correctly. So please pay attention to the very first step. An 8-meter ladder is leaning against a wall and reaches a height of 7 meters up the wall. So this was drawn this way, right? But you might think the wall is over here. So you might draw it this way. Is this wrong?
No.
No, they're both going to be right. Okay, you don't have to draw it this way, but we should get the same answer. What angle with the ground does the base of the ladder make? So it wants to know this angle here. Well, we know it's a wall, so we know that's 90 degrees, right? That's the known, okay? We need to find one more angle. We want this angle. And we're going to use the sides that we know. So because this is the angle we're concerned about, and the two sides that we have are opposite and hypotenuse, that is what's going to make us use sine, the sine ratio, okay? So sine of 61 is equal to 7 over 8. So then you take the sine inverse of 7 over 8 and you get the angle 61. Sorry, yeah. Sine theta, or x, we don't know that it's 61 yet, right? That's what we're trying to solve for. So I skipped a step there. I already knew the answer. It's sine theta is 7 over 8. So this is the unknown angle, theta here. And then when we solve it using sine inverse 7 over 8, we get 61. Okay? But that's known from the height up the wall, 7 meters, and the ladder, which is the hypotenuse, the 8 meters. Okay? So this is the hard part, the setup. This shouldn't have said 61, right? Because that's the solution. It should have said theta. Okay, use trigonometry to find the distance from the base of the wall to the base of the ladder. So now it's asking for this length, right? The adjacent length to theta, right? So we want to know the bottom, we know the opposite, so we can use tan, using that now discovered angle 61. So we'll say tan 61 is opposite over adjacent, 7 over x. We solve for x, x is 3.9. So this here is 3.9. Finally, it says, what other method could you have used to answer question B? Could have used Pythagorean theorem. I don't think so. Oh, yeah, you could have. So you could have said x squared, which is one of the sides, plus 7 squared is equal to 8 squared. Could have done that. Okay. What else could we have done? Yeah? Yeah, you can close the door. I would have said before we used Pythagorean theorem, we could have used cos. We could have used cos 61, because we know cos 61 is going to be equal to our adjacent, which is our unknown, x over 8. Could have done it that way. And then you would just get x is equal to 8 cos 61. That's way easier than this. I would get away from Pythagorean theorem. If you're working with right angle triangles, you want to know anything about the triangle, you're smarter than Pythagorean theorem now. You can go back to all those problems in grade 9 with Pythagorean theorem and use SOHCAHTOA. As long as you have a calculator, and actually I could show you how to do it without a calculator, believe it or not, but you need a really big graph paper. You don't need a calculator for these sine ratios.
Would the person I mean like SOHCAHTOA like one of Pythagoras students or something?
I don't know. It's a good question. It's a good question for ChatGPT. I'm not sure who it was, but smart guy, right? Whoever it was. Last page. Here we go. Let's go. Still have 40 minutes. Definitely doing another lesson. All right. Example 8. An airplane climbs at an angle of 12 degrees. So here's our nice drawing. The hardest part. Airplane climbs. That means it's flying upwards, right? At 12 degrees from the ground. Okay? What is the distance it has traveled to the nearest meter when it has attained an altitude of 120? So the height is 120. How high, once it's got to 120, what is the distance? Now, you might think this is the distance it's asking about, but remember, it's not just driving along the ground like a car. It's actually moving through the air, so it's traveling a greater distance. It is actually asking for the hypotenuse. That would be the biggest mistake, I would think. People would maybe think you're talking about this distance. Okay, so we have our nice setup here. We know this is a right angle triangle. Okay, because we created it, right? Wherever the airplane was, this is the airplane. Ooh, nice airplane. This is the distance straight down from the ground. Way better. Ethan. Are we going to use sine? We're going to use the ratio that involves opposite over hypotenuse. Is that sine? Yes, it is. We're going to use sine. Sine 12 degrees equal to 120 over x. Easy. Baby food here. Let's go. X is equal to 120 divided by sine 12. Five, 7.17, and this is in meters. So what's the distance it has traveled? It has traveled 557.17 meters. Any questions? Okay, that is 7.4.